So in the second half of this unit, we're going to be working on like creating optimal dimensions for things like reducing perimeter, but maximizing area. Because obviously, like if we think about things in terms of real world, like if you're creating a fence and you don't have certain constraints, it's best to use the least amount of fencing for the greatest amount of area that you can cover, right? Versus like using a ton of fencing and then not getting as much area out of something that you would want. So this whole thing is about like optimizing certain dimensions so that you can use minimum amounts of materials and things like that. So we're going to talk about optimizing area and perimeter, so just basically like 2D shapes today. So if we look at the first example here, we can see a bunch of different rectangles. And the thing that I kind of want you to take away from this is that, like this first rectangle here has 2 centimeters by 8 centimeters on each side. We can see that the perimeter of this is 20 centimeters. But I can get the same area, which is 16 centimeters squared, with only a perimeter of 16 centimeters if I just make that area square instead of like a long rectangle. Now, obviously, in real life, sometimes we might have certain constraints that we have to work within, right? So we won't always necessarily be able to make something perfectly square to optimize its area, but this is just an illustration of how we can use less material to get a similar kind of area. This one, the closer we make it to a square, so obviously like 3 centimeters and 5 centimeters, we're still using the same perimeter as the square, but we just get a slightly less area because those dimensions aren't optimized. So one thing that I want you to take away from this is basically like a square, when you have to make some kind of rectangular enclosed area, a square is going to give you the optimal measurements where you minimize the amount of material that you use for the perimeter, but maximize the area inside of it. All right, so one type of thing that we could look at is finding the dimensions of a rectangle with perimeter of 20 meters. That gives us maximum area, and then ask us what is that maximum area. One assumption that we're going to make in this type of question is that the dimensions are whole numbers, but sometimes we can have decimals and stuff like that too, and I'll show you an example of that below. So for instance, if I have 20 meters, one thing that we have to consider is that all 4 sides need to add up to that value. So if I'm thinking about length and width, I want length and width to essentially add up to half of 20, which is 10, because obviously I'm going to have 2 lengths and 2 widths. So for instance, if I make the width equal to 1 meter, then the length has to be 9 meters because that equals 10. And then I'm going to have another 9 over here and another 1 over here. So it's like 10 plus 10, right? Which gives me 20. So I'm looking to make my length and my width some kind of combination of meters that will add up to 10. That way the whole perimeter adds up to 20. So one option is that we have 9 meters and 1 meter, as I said. The rectangle's area is essentially length times width, or base times height. So that's going to give me times 1, which gives me 9 meters squared. What other combos could we have of things that add to 10? What would be like the next one? If I were to shift a unit from here over to here. Like if I made this 8 meters, what would the width have to be? 2 meters, okay. And then if we look at 8 times 2, we'll get 16 meters squared. So obviously that one is a better option than doing 9 by 1, right? What's the next option that we could have? Yep. So 7 meters by 3 meters. That gives us 21 meters squared. Next option. And then last option. So which one gives us the highest amount of area? Okay, 5 by 5, and what does this make sense? Based on what we just discussed above with these, why would it make sense that 5 by 5 would be the optimal dimensions of this? Right, because we said a square basically optimizes that, right? So it gives you the most amount of area for the perimeter that you have. Okay, so we're gonna just like make a note here that a square, 5 by 5 meters squared, gives us the largest area of 25 meters squared. And just as a reminder, squares produce the maximum area. So you can add that to your note. And I'll just say for a given parameter. Now, some perimeters, we might not be able to make a perfect square. So for instance, if you had 19 meters or something like that, and you couldn't go, like if it was saying you were using all dimensions that are whole numbers, you wouldn't be able to get something like 5 by 5, right? It would have to be the closest you can get to a square, like the closest you could make those whole measurements. So for instance, it would be like 9. Sorry, thinking about like, let's say if it were 18, for instance, that would be an easy one to do. You'd have 4 by 5 because there's no way that I can create whole numbers. That's like the closest that I can get of those two dimensions, right? 19 would probably have to be like, what would be the optimal balance of dimensions that are closest together? I guess 19 doesn't quite work if it's an odd number. No, it still would work. What do you think? I guess it actually doesn't work if it's an odd number. You'd have to do decimals. Yeah. Okay, so that's fine. So like 18 is a good example. You'd have to do 5 and 4. Okay, so then it asks us what are the dimensions of a rectangle with area 45 meters squared and the minimum perimeter. So this time it's giving us an area instead, and then we have to find the minimum perimeter that you can get out of that. Obviously, like in real life, we want to minimize certain like surface areas, like if we're building walls or whatever, we could potentially minimize the surface area of the walls that we would have to create or a fence or whatever. So the way that you can do this is if you're not looking for whole numbers, you can actually take the square root of the area to find the length, the optimal length of a side if you're making it a square. Okay, so remember that we're looking for dimensions of a square. So that means base times height are essentially equal, or length and width are equal. So I can find the length, which is also equal to the width here, by doing the square root of whatever area is given to me, because it'll essentially be times length or width times width in that calculation. So if we do the square root of 45, it should give us the optimal dimensions, and then we can find the perimeter from there. So what do you get for square root 45? We'll just go nearest tenth. Okay, so 6.7 then. Okay, so that means your width and your length are both 6.7. You'd have a 6.7 by 6.7 square. And then how do I find perimeter of something like this? What does perimeter mean? Yeah, so like the lengths, all the lengths and widths of that added up. So how do I find it for a 6 by 7, 6.7 by 6.7 square? Yep, or I can multiply it by 4, right? Because I have 4 sides that are 6.7 meters. Because we're doing technically 6.7 plus itself. Like we're adding it 4 times. So that would be the same as 4 times 6.7. 4 sides that are 6.7 meters in length. What do you get? Great. 26.8 meters. So when we talk about area, we'll talk about like units squared because we're talking about like the whole inside of it. But perimeter is just whatever units you're working with because you're literally just adding the meters of each side, right? Okay, so then therefore a square of 6.7 by 6.7 meters will give us a minimum perimeter of 26.8 meters. Perfect. Okay, optimizing when we have a rectangle that is connected, is bordered by something. So a rectangular garden is to be fenced using the wall of the house as one side. So we only have 3 sides of our garden. The garden should have an area of 40 meters squared. Determine the minimum perimeter and the dimensions of the garden, given that the dimensions must be whole numbers or of meters. There'll be some questions in the homework where we're going to do some decimals, and I have a couple little tips on those homework questions that will allow you to optimize those ones as well. So if we're doing whole numbers in order to find the area of 40, we're basically just going to start and look at all the combinations that give us multiples that will equal 40 meters squared. So the first option would be 40 times 1. 40 times 1 gives us 40 meters squared. Now remember, we have two widths here. This is a width, and this is a width, and then we have one length. So when we go to find the perimeter, we're going to do 40 plus 2 of those widths, 1 plus 1. So that would give us 42 for the perimeter. What's the next combination of factors that multiply to 40? 40 and 1. So that doesn't multiply to 40 though. I'm looking for factors that multiply to 40 because we're trying to get an area, right, for this one. So the next one would be 20 and 2. 20 times 2 gives us 40. So I have 20 plus 2 plus 2, which gives us 24 meters for perimeter. So automatically we could see that one's a better option than doing a 40 by 1 area. What's the next option of combination that multiplies to 40? 3 doesn't work. Does 4 go into 40? You can try to divide 4 into 40. Okay, so 10 and 4. So we'd have 10 plus 4 plus 4. And that gives us 18 meters. So that's an even better option. What's the next option? Does 5 go into 40? Okay. So we'd have 8 plus 5 plus 5. What does that give us? Okay, does 6 go into 40? 7? 8? 8 doesn't go into 40? Okay, so we could have 5 times 8, and then that makes our perimeter 5 plus 8 plus 8. So that's going to give us how many meters for the perimeter? Okay, 21 meters. So we can start to see that these are kind of giving us optimal perimeters, and we're probably going to be working our way up now. So for instance, if we did 4 and 10, we're basically just swapping these two options around. We're going to have 4 plus 10 plus 10, which gives us 24. So we can see that somewhere in the middle here, we reached like an optimal perimeter, and now we're going up in perimeter as we kind of swap the order of which one's the length and which one's the width, remember, because we have 2 widths and only 1 length, right? So I don't think we need to go any further and like swap these. We could do 2 and 20 and 1 and 40, but we can already see that the perimeter is growing. So we must have reached it somewhere in here. So we have 2 options, right? We could do 10 by 4 or 8 by 5. They're both giving us optimal perimeter. So this one has 2 answers. We'll say the garden could have length of 10 meters and width of 4 meters, or length of 8 meters and width of 5 meters with a minimum perimeter of 18 meters. Okay, and obviously if there aren't 2 options, you just choose the one that has the lowest option. So far so good? Any questions? Okay. And then we're going to look at enclosing non-rectangular areas. So suppose a farmer is creating a fenced exercise yard for her horses. All right, she has 900 meters of flexible fencing and wishes to maximize the area. She is going to fence a rectangular or a circular area. Determine which figure encloses the greater area. Okay, so if it's rectangular, this means that it has to be some kind of square. If it's circular, obviously it's just a circle, right? And then we can decide on the best radius of that circle. So we're going to do a comparison of if this were a square. All squares are rectangles, right? So that fits into the category of rectangle, or if a circle gives us the better option. So if she has 900 meters of flexible fencing, what is this telling us? Is this area or is this perimeter? Yes. So perimeter equals meters. So if we were to create a square out of that, what are the optimal dimensions of our square if it has to add to 900? So basically, if I take the perimeter and I divide it into 4 equal sides, that should give me the optimal dimensions of the square, right? So if I just do that, the length of a side of the square needs to be 900 divided by 4, that makes it all equal dimensions. Agreed?
Yeah.
Okay, so what does that give us? Okay, so that would be 225 meters for all sides of the square. What does that make the area? How do I calculate the area of that square?
225
Yeah. No, that would be perimeter. That's going to give us 900 back. How do I calculate area of a rectangle or a square? Base times height, or length times width. Area is length times width, and if length and width are equal, you're just doing 225 times 225. Get the area. Perfect, and that is meters squared. So then we're going to compare that to a circle. And this means, like, if the perimeter of a circle is 900, that is basically talking about the circumference of the circle. So we're saying that the circumference of a circle is equal to 900 meters. Okay, because you technically don't have like a perimeter of a circle, it's just called circumference, right? So we would have to set the circumference formula for the circle equal to 900 and then solve for the radius that makes the circle have that particular circumference. So circumference of a circle is 2 pi r. And we're going to set circumference equal to 900 meters. And then our job is just to solve for radius. So how would I get radius by itself here? Yep, 2 pi actually, because we just want r by itself. So we're going to do 900 divided by 2 pi. What we get for radius, we'll round to the nearest tenth here. Does it round to 143.3? Oh no, it doesn't. You're right. 143.2. And then we're going to use that to calculate the area of the circle. So area of a circle is pi r squared. And we'll see what that gives us out. And then we'll compare and see which one gives us the better option. Okay. What's the unit of measurement? Close. For area? Nope, that's volume. So squared, meters squared. Okay, so on one hand, we have the area of the square giving us 50,625 meters squared. And then on the other hand, we have the area of the circle, which gives us 64,422. Which one is the better option for optimizing the area? No. We want, when we say optimizing area, we say we want the maximum area.
Oh.
Great. So the circle will optimize the area when the radius is 143.2 meters. Just as a note, we're going to write down circles. If you don't have to have a rectangle for your particular shape, circles are always going to be the optimal shape to give you the maximum area possible with the smallest amount of perimeter used. So circles are always the best option. They're even better than squares as far as minimizing perimeter and maximizing area. Okay, so circles are the optimal shape to minimize perimeter and maximize area.